Hello, everyone. It's nice to see you here this evening or this morning. Lisa's based in Denver, so it's morning for her. My name is Anna. For those of you who don't know me, I work at Elastic on the EMEA community team. This is a joint meetup between PyLadies London and the Elastic EMEA virtual user group. So welcome, everyone. Just a few housekeeping items before we get started. So this event falls under the Elastic Code of Conduct and also the PyLadies Code of Conduct. So I hope that nothing will happen. So please behave. No, I'm just joking, but we do care about people's safety. So yeah, please be nice to everyone. Also, Lisa would prefer to take questions after her presentation. And if you see down in the Zoom bar, there is a Q&A tab on the right side. So please post your questions in the Q&A tab and not in the chat. That'll be easier for us to keep track of your questions. I will post a few links in the chat as Lisa continues with her presentation. So everything will be there. Also, we are recording this meetup and we will make the video available to you all tomorrow. So if you can't make it for the whole duration of the meetup, or if there's anything you would like to look up afterwards, the video will be there. Yeah, and then I think that's it. I don't think I forgot anything. And then, yeah, I would like to welcome my awesome colleague, Lisa, developer advocate at Elastic. She's based in Denver, and she's going to do her beginner's crash course to the Elastic Stack series, part 1 introduction workshop. So handing over to you, Lisa.
Oh, wow. Thank you so much for the great intro. Hi, everybody. Welcome to the beginner's crash course to the Elastic Stack. My name is Lisa Jung, and I'm a developer advocate at Elastic. So today, I'm going to give you a crash course on Elasticsearch and Kibana. And I'm going to kick this off with a question. So who here has ever used the Elastic Stack before? So in the chat window, type yes if you have used it, and type no if you have never used it. Oh. Oh, wow. So there's like a huge mix of people. So it does seem like there are some people in the audience that have never used it before. But even so, you may be using a lot of apps with certain features that are powered by the Elastic Stack. For example, if you have ever searched for a ride on Uber, Elastic is the engine that powers the Uber marketplace that connects you to the driver. Now, if you ever had mad cravings for tacos and were searching for open restaurants on Yelp, Elastic is powering that search. So it's hidden under a lot of the apps and websites that you use on a daily basis, which few of them are shown here. So what is the Elastic Stack exactly? Now, if you're a developer working with data, the Elastic Stack is a great tool to have on your belt. Now, it consists of 4 products: Beats, Logstash, Elasticsearch, and Kibana. And with a stack, you can take data from any source in any format, then search, analyze, and visualize in real time. So some of the most popular use cases for the Elastic Stack are logging, metrics, security analytics, and business analytics. For example, the Elastic Stack is used to store and analyze log data. And a specific example for all the gamers out there, Blizzard uses the Elastic Stack to analyze gamer and server events. So if the players experience a slowdown or an error, their monitoring team would use the Elastic Stack to figure out what's causing it. Now, it could also be used to gather metrics. And one of my favorite examples is the Mars Curiosity rover. So it sends telemetry, sensor, and photo data into the Elastic Stack for analysis. So if someone wanted to know how hot Mars is on an hourly basis, you can go and pull the data. Now, with the Elastic Stack, you could analyze security issues and threats within an environment as well. So you probably have used Slack at work or at meetups before. And what you may have not realized is that Slack uses the Elastic Stack in their security operations center to secure communications through their channels. Now, lastly, if you have ever used Tinder, you probably didn't realize that the Elasticsearch was helping you find your match. So, this is a technology behind using geolocations to match people together. And it's also used to analyze business needs and build custom applications so you could analyze and learn from the data. For example, Tinder relies on the Elasticsearch to analyze and predict which people a user will swipe right on or which people will swipe right on that user and when there's a match. So all of these use cases are made possible by the Elastic Stack. And with the stack, you can take data from any source in any format, then search, analyze, and visualize it in real time. Now, it's a collection of 4 products. First, we have Elasticsearch, which is the heart of the Elastic Stack. It allows you to store, search, and analyze your data. Then we have Kibana, which is a visualization tool. And it's a UI that helps you visualize and explore data in Elasticsearch. Now, in order for us to work with data, we need to get data into Elasticsearch, right? And this is where Beats and Logstash come into play. So Beats are lightweight data shippers that push data into Elasticsearch. And if you need to parse and enrich your data before pushing data into Elasticsearch, then you would use Logstash. So, Beginner's Crash Course is a series of workshops, and throughout the series, we'll delve into each product, learn when to use it, and how to use it. So, by the end of the series, you can identify which products of the Elastic Stack would best serve your use case and know how to get started with these products. And today, I'm going to introduce you to Elasticsearch and Kibana. So here's the game plan. We'll start off by going over a scenario where Elasticsearch and Kibana could come in handy. Then we'll go over the basic architecture of Elasticsearch, and we'll wrap up by running CRUD operations with Elasticsearch and Kibana. So let's get started. So Elasticsearch is known as the heart of the Elastic Stack, and this is where you could store, search, and analyze your data. So let's go over a scenario where Elasticsearch may come in handy. Now imagine you're the lead developer responsible for building and maintaining an online grocery shop. And using the search bar, millions of customers will be searching for products that they want to buy. Now, a great search experience is key to have your customers to buy and keep coming back to your platform. And we want the customers to get fast and relevant results no matter the scale. And another important factor in search experience is relevancy. So, the whole point of search is finding relevant data fast. And we want to be able to fine tune our search experience to get the information we want. We also want most relevant results at the top and the least relevant at the bottom. So, for example, let's say a customer is searching for peanut butter and there are a ton of different brands. So, what if a customer wanted to see peanut butter from highest to lowest rated brands? Or what if the customer is searching for sriracha hot sauce and misspells it? Well, we still want to pull up relevant search results, even though the customer spelling doesn't exactly match the product data. So, if you're in a situation where speed and relevance of your search is an important aspect of your work, Elasticsearch could come in really handy. So, how does it look when Elasticsearch is connected to your app? Well, when a user sends a search request from your website, the request is sent to the server, which sends a search request to Elasticsearch. Now, Elasticsearch finds and sends the results back to the server, which processes the info and sends the results back to the browser. Now, let's go one step further. So, through your app, you're collecting a lot of data, such as order information, purchase history, the list goes on and on. And we want to make use of that data. For example, we want to know what was the revenue for the last month, or which products are most popular. So to answer these questions, you can enter relevant data in Elasticsearch, so you can search and analyze your data to answer your question. But data is so much easier to understand if you could visualize it. And this is where Kibana comes in, which helps you to visualize and manage your data. So think of Kibana as a web interface to data stored in Elasticsearch, and it allows you to search, view, and interact with Elasticsearch data. So if you had a question about what is the most popular product or what was our revenue last month, you would enter relevant data into Elasticsearch, and from Kibana, send requests to Elasticsearch to get and analyze the data you want. Now, on top of that, you'll be able to create a dashboard with Kibana, so you could visualize data in a variety of charts, tables, and maps. And this way, you can get insights more easily and be able to share that with your stakeholders. So if you're in a situation where you need to analyze and visualize data inside Elasticsearch, Kibana will come in really handy. Okay, so now that you understand when to use Elasticsearch and Kibana, we'll move on to the basic architecture of Elasticsearch. So Elasticsearch is a powerful search and analytics engine, and it's known for its distributed nature, speed, and scalability. And this is due to its unique architecture. So when Elasticsearch is up and running, you now have an instance, also known as node. And each node has a unique ID and a name, and it belongs to a single cluster. And we'll get to what that is in a little bit. So when you start up a node, a cluster is formed automatically, and you can have one to many nodes in a cluster. And these nodes are distributed across separate machines, but they all belong to the same cluster and work together to accomplish a task. So let's really bring this concept home. So think about a team that you have been a part of, and your team consists of multiple members who all work together to accomplish a common goal. Now, your team could divide and conquer by assigning each member one or multiple roles, and these are the roles that you're going to specialize in. Now, your team members may work in different buildings, but you all still belong to the same team. And this analogy directly applies to nodes in a cluster. For example, nodes are members of a cluster that share the same goal, and nodes are distributed across separate machines, but they are still a part of the same cluster. Nodes are assigned to one or multiple roles, and one of the roles that a node could be assigned to is to hold data. And that is what we'll be focusing on today. So data is stored in Elasticsearch as documents, and a document is a JSON object that contains whatever you want to store in Elasticsearch. So let's go back to our online grocery shop example. And we're helping our customers search for grocery items online. So we need to store grocery data in Elasticsearch. Now, a document for one grocery item would look like this. So in a JSON object, it contains a list of fields or key value pairs. For example, it has the name of the product, the category it belongs in, the brand, and price. And things are easier to find when you group them in a logical manner. And documents that share similar traits and are logically related to each other are grouped into an index. So for example, documents of clementines and carrots will be grouped under the produce index, and documents of Malbecs and IPAs would be grouped under the wine and beer index. So to sum it up, indices are used to group documents that are related to each other, so we know where to find certain information. So let's delve into this a little bit more. So here we have a cluster of nodes, and we have a produce index and wine and beer index. Now, index is not actually storing documents. It's just a virtual thing that keeps track of where documents are stored. Now, you can't find index on disk. What actually exists on disk is a shard. So shard is where data is stored, and this is where you run a search. Now, when you create an index, one shard comes with it by default, and you can also configure it so that you could create an index with multiple shards that are distributed across nodes. And this is a practice called sharding. And there are a lot of superpowers that come with this practice. So let's say you have a cluster that looks like this, and you want to create a produce index that will keep track of all produce documents. And when you create an index, one shard is created by default, and the shard is assigned to a node. Now remember, shard is where documents are stored, and the number of documents a shard could hold depends on the capacity of the node. So let's say you want to index 600,000 documents in your produce index, but the node the shard is assigned to could only hold 200,000 documents. Well, that's not going to work, right? Well, we do have two more nodes which could hold 200,000 documents each. So what you can do is you could add two additional shards in the index and distribute them across these nodes. And each shard could hold 200,000 documents. So together, they could hold 600,000 documents. Now, that's all fine and dandy, but our produce data is only going to grow. So how are we going to adapt to increasing amount of data? Well, that is the beauty of sharding. So you could add more shards and nodes as a need arises. So you could horizontally scale and adapt to increasing number of data. But that is not the only superpower that comes with sharding. Now remember, shard is where you store documents, and it's also where you run search. So let's talk about a scenario where a client is sending a search request for pink lady apples. Now, in this scenario, you have one shard in a node that could hold the entire produce index. And let's say the produce index keeps track of 500,000 documents. And we're going to run a search in the single shard, meaning we'll go through 500,000 documents sequentially. So let's say it takes you 10 seconds to do that. Now, this time, we're going to run the same search with a different setup, and we'll have 10 shards distributed across 10 nodes, and we'll distribute 500,000 documents across 10 shards so that each shard holds 50,000 documents each. Now, in the previous scenario, it took us 10 seconds to sequentially search through 500,000 documents. And if you do the math, running a search on 50,000 documents should take 1 second. And what's so cool about this setup is that you could run a search on all 10 of these shards at the same time in parallel. So now guess how long it takes to search through 500,000 documents with this setup? 1 second. So as you can see, sharding could really speed up your search. Now with the first setup, one node had to store all the info and process all incoming search. And with this setup, we could only store as much data and process search requests as a single machine. And with the second setup, we distributed data across shards and allow shards to process search requests in parallel. So not only do we have the capacity to store more data, we can now search at scale. Now, let's say everything is going well with our online grocery shop, but all of a sudden, one of our nodes goes down and our data is lost forever. That would suck, right? And we want to avoid this at all costs. So what we could do is you can make copies of the original shards and store its copies across different nodes. Now look at nodes 1 and 2. And these nodes contain our original shards, also known as primary shards. And that is what P stands for. Now we're going to make copies of each shard and store these in nodes 3 and 4. And these are known as replica shards, and that is what R stands for. Now, R0 is a replica shard of primary shard 0, and R1 is a replica shard of primary shard 1. And what this does is that if one node goes down, everything is okay because we have a replica. of our data somewhere else. Now, that's not all. So there's an additional superpower that comes with replica shards, and that is improving the performance of your search. So let's say you have two primary shards distributed across two nodes, and you're currently getting 2,000 search requests per second. And these search requests are being ran in these two primary shards. As our app is getting more popular, the search requests have now increased to 8,000 requests per second. And because of that, your two primary shards are having trouble keeping up with the demand. And to solve this, you could add more nodes and increase the number of replica shards of P0 and P1. Now remember, these replicas are identical copies of primary shards. And with the new setup, these replica shards can pick up the slack, and your cluster could better handle increased demands on search. Okay, so now that you understand the basics of Elasticsearch, we're going to move on to the tutorial. And we'll finally get to play with Elasticsearch and Kibana. And the goal of this tutorial is to get familiarized with CRUD operations. So in other words, how do we create, read, update, and delete a document from Elasticsearch? So to do this, we're going to use Elasticsearch and Kibana. Now, there are multiple options for accessing these two products. So one option is to use Elasticsearch and Kibana hosted on Elastic Cloud. Now, this handles all the heavy lifting of managing the stack, so you can focus on building your product. So you get a free 30-day trial with this, and there's no credit card required, and the trial expires on its own. And I find that for beginners, it's easier and faster to get started with Elastic Cloud. So I'm going to show you how to do that today. Now, another option is to download Elasticsearch and Kibana on your local machine and manage these on your own. Now, this option is free and there's no expiration date. Now, I wrote a blog on how to get started with a downloaded option, and this blog is included in the Github repo that we're about to share with you. So here we have the link to the GitHub repo for today's workshop. Oh my God, Anna, you're so on top of it. Thank you. So Anna just dropped the GitHub repo link in the chat. So go to this link and have this pulled up. And you'll see this on your screen. So this repo contains all the resources that are shared during this workshop. And if you scroll down to the resources section, you'll see a link to free Elastic Cloud trial. Now you'll right click on that and open the link in a new tab. And the link will take you to the free trial page. Now, I'm going to breeze over the setup because I don't expect you to set this up during the presentation. I just want to show you what you need to do. So if you want to try this out on your own, you can watch the recording and get started. So to get going, enter your email and click on Start Free Trial. Once you do that, it'll ask you to go to the email account you signed up with and verify your email. So go to your inbox and click on Email from Elastic, then click on Verify and Accept button. And it'll prompt you to set your password. And once you set your password and log in, it'll take you to this page where you'll click on Start Your Free Trial. Now next, you'll select the Elastic Stack. And when you do that, you'll see this drop-down menu where you can configure your settings. Now, if you look under Select Hardware Profile, Elasticsearch offers several deployment templates for different use cases and workload. Now, each template selects the appropriate cloud hardware configuration for different needs. But if you're just getting started or don't quite know your needs yet, then go with the recommended IO optimized option. Then you would choose the cloud provider of your choice. So let's say you have an app and you want to integrate Elasticsearch. So if your app is running on Google Cloud, you don't want Elasticsearch running on a different cloud provider because that'll cause latency issues. But for what we're about to do, it doesn't matter which one you choose. So just select one. Then select the region close to you. and select the latest version of the Elastic Stack, which at the moment is 7.11.1. Now, if you scroll down, you can name your deployment to whatever you want. I name mine Beginner's Crash Course, then click on Create Deployment. And once you do that, you'll get your deployment credentials. And you'll need this when you add data to Kibana. So either download the credentials or save it somewhere else, as these are only shown once. And when you click on download or continue without downloading, it'll create your deployment and load Kibana. Now, once everything is loaded, click on Open Kibana. And after that, both Elasticsearch and Kibana are ready to go. Now, we're going to pull up the Kibana console now. And when you advance to the next page, click on Explore on My Own option. And it'll take you to this page here. So click on the menu icon in the upper left corner and scroll all the way down to Management section and click on DevTools. Then it'll take you to the Kibana console. Now click on Dismiss and delete the delete the default query shown here. Now we're ready to use Kibana to send requests to Elasticsearch. Now, before we get to the CRUD operations, let's take a step back and look at the big picture. Now remember, Elasticsearch is a search engine. So when a user sends a request from your website, the request is sent to the server, which sends a search request to Elasticsearch. And Elasticsearch will then find the info, send it back to the server, which processes the info and sends the results back to the browser. And the same process can be mimicked and tested with Kibana, which is a UI that communicates with Elasticsearch. And when you deploy an Elastic Cloud, Elasticsearch and Kibana are automatically prepped and ready to go. And the cloud automatically creates multiple nodes that are grouped into a cluster. Now, as you know, Elasticsearch is receiving search requests and sending the results back all the time. And this communication is handled by HTTP requests. Now, in the tutorial, we'll be learning about the requests that we could send to create, read, update, and delete data in Elasticsearch. So before we get started, let's get organized a little bit here. So I have two windows open side by side. So on the left, I have Kibana console open, and on the right, I have the workshop repo. Now, go to the browser where we have Kibana open, and this is divided into two panels. So on the left is where we enter the request that we want to send to Elasticsearch, and on the right is where you'll see the response from Elasticsearch. So we're going to start by checking the health of the cluster. So look to the right to your repo and scroll down to getting information about cluster and nodes. So we'll be sending an HTTP request to Elasticsearch, and this is the syntax that we're going to use. So first, we specify the HTTP verb get, followed by the name of the API that we want to get information from, and the parameter that gets the information that we want. So in our example, what we're saying here is get from cluster API health information about our cluster. So let's copy and paste that into the console. Make sure to click on it. There's a dark gray bar over it, and click on this green arrow to send the request. Now, you'll see that a response has been returned from Elasticsearch, which shows you the cluster name. And you'll see that the status has been set to green, which means that our cluster is healthy and ready to go. And if you look at line number 5, you'll see that the Elastic Cloud has automatically created 3 nodes by default. All right. So next, we're going to get more information about our nodes. So let's go back to the repo and scroll down to get information about nodes in a cluster. And what we're saying here is get from nodes API stats about our nodes. So let's copy and paste that. Oops. Make sure to select it and send. Now you'll see that we have a total of 3 nodes that belong to this cluster here. And you'll see a lot of information such as the host, IP address, roles, attributes, and etc. Now we're not going to get into these now, but just know that this request is really helpful if you ever have to debug a node because it allows you to inspect the nodes more in detail. All right. So we're going to move on to the CRUD operations. So in other words, how do we create, read, update, and delete a document? Now for this exercise, we're going to store documents about our favorite candy. Now, by now, you know that documents are logically grouped into an index. And as a best practice, we're going to create an index first. So let's go back to our repo and scroll down to create section. To create an index, we use a HTTP verb put, followed by name of the index. And since we're going to be indexing documents about our favorite candy, we named our index favorite candy. So let's copy and paste that. Make sure to select it and send. Now, when you see acknowledge true, it means that an index named favorite candy has been successfully created. Okay, so now that we have an index, let's index some documents. Now, this time I'm using index as a verb to mean that we're storing documents in Elasticsearch. So let's scroll down to index a document section here. Now, this is C, the create part of our CRUD operation. So when you're indexing a document, you could either use post or put, and you would use post if you want Elasticsearch to auto-generate an ID for your document. Now, the syntax you follow is post followed by name of the index, followed by the document endpoint, followed by the JSON object with whatever data that you want to store in Elasticsearch. So in our example, what we're saying here is to post in favorite candy index the following document, and the fields that our document contains are first name and candy. So let's copy and paste that into the console. Make sure to select it and send. Now you'll see that in the index favorite candy, a document with an auto-generated ID has been created here. Okay. Now let's turn to your repo and scroll up a little to index a document. Now, we just went over, we said when indexing a document, both HTTP verbs post or put can be used. Now, we just went over post, so we'll move on to when you would use put to index a document. So scroll down to put. Now, you would use put if you want to assign a specific ID to your document. And a time where you might want to use this is when you're indexing data with a natural identifier. So for example, let's say you're indexing patient data where each patient has a unique ID. And documents may be easier to work with if it had the same ID as the patient ID, rather than some auto-generated ID that has no meaning. So this way, it's easier to keep everything uniform across multiple data sources. Now, this time, we're going to index a couple more documents using put. So if you look at the repo, you'll see that the request starts with put, followed by name of the index, then the document endpoint, and the ID that you want to assign to this document here. So in our example, what we're saying is put in favorite candy index the following document and assign it an ID of 1. So let's copy and paste that into the console. Make sure to select it and send. Now you'll see that document with an assigned ID of 1 has been created. Now, you'll notice that version number is 1 right here. Pay attention to that because we're going to come back to this in a little bit. All right. Okay, so let's index a couple more documents, and I'm going to copy and paste the request that we just sent twice below. So for this one, I'm going to say Rachel's favorite candy is Rolo. And I just realized that I'm giving this talk in London, so I'm not quite sure what American candies that you're familiar with, but bear with me here. And I'm going to give this document here an ID of 2 and send it. Now you'll see that document with an ID of 2 has been created, right? Let's do the same thing for Tom, who likes Kit Kat. And I'm going to give this document an ID of 3, and I will send the request. Now you'll see that document with an ID of 3 has been created. Okay, so now that we have indexed some documents, I want to send a request to see the content of the document that has been indexed. Now, this is the read part of CRUD operation. So turn to your repo and scroll down to read. And the syntax we're going to follow is get followed by name of the index, then document endpoint, and ID of the document that you want to retrieve. So what we're saying here is get from favorite candy index document with an ID of 1. So let's copy and paste that. And I'm going to paste that below John's document here because this is document 1. Now let's send the request. Now you'll see that document with an ID of 1 has been retrieved. And if you look at under source field on line 9, you'll see John's information that we just indexed. So this is a great way for you to check whether our CRUD operations have worked or not. Now, what do you think would happen if we accidentally index another document with an existing ID? Well, we're going to find out. So go back to the request for document 1. I'm going to copy and paste that below. So let's say we're going to index a document that says Sally loves Snickers. And let's say we forgot to change the ID and we index a document with an existing ID of 1. So let's send that request and see what happens. Well, it's a little different, right? It says document 1 has been updated and the version number is now 2. So what this version number is telling you is the number of times a document has been either newly indexed, updated, or deleted. So far, the document with an ID of 1 has been indexed with John's information, and we accidentally updated it with Sally's info. So therefore, the version number is now 2. So let's send a GET request to see the content of document with an ID of 1. So we'll go back to this old request that we sent beforehand and send it. And if you look at source, you'll see that John's information has been replaced with Sally's. Well, that's not good, right? Because when you're indexing your data, you don't want to accidentally overwrite your existing document. Now, in order to prevent that, you could use the create endpoint. So turn to your repo and scroll up to create endpoint. Now, the syntax that you use is put followed by name of the index, then the create endpoint, and the ID that you want to assign to this document here. So in this example, what we're saying is put in favorite candy index the following document and assign it with an ID of 1. However, if an document with ID of 1 already exists, then don't do anything. Just throw an error. So let's copy and paste that below Sally's information here. And I'm going to select it and send. Now you'll see a 409 error. And the reason for that is because the document already exists. So the create endpoint worked just as it should. But let's double check and take a look at the content with a document with an ID of 1. Now, you'll see that Sally's information is still there. So the create endpoint provides a safeguard for you so you don't accidentally overwrite your document. Now let's scroll down to update. And there will be times where you want to update an existing document. So for example, let's say Sally originally liked Snickers, but she changed her mind. Her favorite candy now is M&Ms. So let's go back to our repo. And the syntax you're going to use is post followed by name of the index, then the update endpoint, and the ID of the document that you want to update. Now, in a JSON object, make sure you add doc as a context here. And what this is telling you is only update the fields specified in this inner bracket here. So what we're seeing in our example is post in favorite candy index. I want you to update the document with an ID of 1, but please note that I only want to update the field candy with M&Ms. So let's copy and paste that. And I'm going to paste it below Sally's information again. Make sure to select it and send. Now you'll see that document 1 has been updated and the version number is now 3. And that makes sense because document 1 has been originally created with John's information, then accidentally overwritten or updated with Sally's. Then we intentionally updated the field candy with M&Ms. So let's make sure the document 1 is updated correctly. So I'm going to send this GET request for document 1 here. And you'll see that under source, Sally's favorite candy now is M&Ms. Okay, last but not least, what if we want to delete a document? And this one is super simple. And the syntax you follow is delete followed by name of the index, document endpoint, and ID of the document that you want to delete. So here we're saying delete from favorite candy index document with an ID of 1. So let's copy and paste that below. Make sure to select it and send. And you'll see that document 1 has been deleted and version number is now 4. But I'm just going to double check and send a GET request for document 1. So I'm going to go back to the old request that we've been sending here and send it. Then you'll see that you'll get a 404 error and found is equal to false because document 1 no longer exists. All right, so those are all the requests that I've got for you. So let me switch back. Now we went over a lot, so let me see if you guys asked any questions in the Q&A section. Oh, we got 2 here. Okay, so Marina asked, do you know why so many shards are created by default? It has shown 40. That is such a great question. So this is actually not true. So I've been actually giving this workshop multiple times and creating the index multiple times. And that's why you see so many shards there. You won't see about like 40 shards. That's too many. That was my fault, my bad. Okay. And the next question is, what is the significance of underscores at the beginning of attribute labels of the return JSON? Are you speaking of these here, Mary? I'm assuming so. I think this is just a syntax that people just agreed upon. And there's like no really significance more than that, I think. It just like makes it easier to read, I believe. Okay, so what is the benefit? Teresa asked, what is the benefit of using Elasticsearch over, let's say, an example database? So Elasticsearch is very geared towards the search aspect. So even if somebody misspelled something, or if you wanted to create a search experience where most relevant results are up at the top and least relevant results at the bottom, or if you wanted to really customize what type of search results that a user will see, Elasticsearch gives you the tools to help you create that experience. I would say that is the benefit of Elasticsearch over database. Any other questions? Going once? Going twice? Oh, there's another one. Okay, so what will happen if you use post to create, but specify ID field in the request body? Will it be used or ignored? Let's try it. Okay, let's see. Let's go back to our post request here. Specify the ID. I've actually never tried this, so I'm glad you brought that up. One. All right, so let's make sure to select and send. Yeah, so field ID is a metadata field and cannot be added inside a document. So that actually doesn't work. So if you want to assign a specific ID, then you will have to use put. Anything else? Okay, so let's move on. Okay. Oop. Sorry, let me get organized here. Okay. So if you like this workshop, we have more in the series for you. So the series started back in December of last year, and the parts 1, 2, 3 are currently available. Now on your screen, you'll see a link to a GitHub repo. So Anna, would you please drop the link on the table of contents? And oh, you're amazing. Thank you. Now, this repo contains a table of contents for all the workshops that have taken place thus far. And you could access all the videos, presentations, and resources to move forward. Now, I currently give these live workshops in the US time zone. However, I'll be continuously updating this table of contents. So if you want to continue on, you can always go back to this repo. Now, if you have any questions about Elastic, the discussion forum is a great place to get your questions answered. And we have a community of developers and developer advocates that answer questions on this platform. So feel free to post your questions here. And last but not least, I often blog about Elasticsearch. So if you prefer to learn by reading instead, then be sure to check out my blog. And that is a wrap. So thank you so much for coming, and I will turn the floor over to Anna.
Awesome. Thank you so much, Lisa.
Thank
There were,
you.
I think, a couple more questions. I don't know if you have time to answer them.
Let's see. Sure, let me, okay. Okay, Steve asked, I guess you're showing the hosted version of Elasticsearch. Yes, this is hosted on Elastic Cloud. Is this free to use up to a point? When would you start being charged? So you get a free trial for 30 days, and afterwards you'll have to, you'll get charged afterwards. However, there is a downloaded version of Elasticsearch and Kibana, and that is free and there's no expiration date. And if you look at the repo, you'll see the link to a blog that explains how to get to that step by step. But this option, you'll have to self-manage everything on your own, and all the benefits that come with Elastic Cloud will not be available there. Okay, did I miss any other questions other than?
I think there's 3 more in Q&A.
Give me 1 second. Let me go back there. Okay, so, and the same with ID that already exists. Oh, this is Marina's question. 1 second. So earlier we were talking about what would happen if we include the ID field under the post request. And she was asking if the same would happen with the ID that already exists. Yes, because actually, hold on, let me Okay, so I just created document 1 since we deleted in the past. And I'm going to send this request here with an ID of 1 with the post request, and we get the same error message. Now, okay. Let's see. I see some of the questions that I do not have the answers to. So there's a question about string search to a request and libraries for different languages and web frameworks, and also automate populating the data from a language like Python. So if you wouldn't mind posting this in the discussion forum here, somebody from our team should get back to you right away. I apologize, I don't have the answers. I am still learning all of this because I'm new. So sorry about that.
Oh, that's fine. Thank you so much, Lisa.
Of
This was
course.
great. I've been at Elastic for 4 years, and I think this is the first time I understood some concepts. So thank you so much for doing an amazing job. Actually, I forgot to tell you this, Lisa, but I would like to give the floor to Anna. Anna approached me about starting a PyLadies London book club.
Oh,
So she will just talk about her idea for a few minutes to see if people are interested. Anna,
sure.
I'm promoting you to panelist, and then you should be able to talk. Anna, are you there?
Yes, I am here. Sorry.
Okay, great.
Video? Okay, I can just speak. So, hi, I cannot start screen sharing. I will just speak. Hi, so my name is Annalie Brown. Actually, I'm a PhD student at University College London. And one thing I kind of noticed in myself is that right now I'm actually doing bioinformatics, which has a lot of packages in R, and my Python has gotten a bit rusty because of it. And I thought one thing that people could kind of use, what has helped me to stay on track recently, is an online book club. So I kind of got together with some other UCL students. I also reached out to PyLadies London to ask if they'd be interested. We've started a Slack workspace, and I've set up an email account for it if you want to contact me here. The basic idea would be to meet approximately every other week on Zoom. We have 2 books that people are really interested in doing, either problem solving with algorithms and data structures using Python, or hands-on machine learning, both of which you can find online for free, although I'm not sure the PDF that's kicking around for hands-on machine learning is entirely legal. Yeah, that's kind of my pitch. Please email me, or you can find the sad little Twitter account I made for this, which has 1 tweet there, or the bit link is a join link for the Slack workspace. Yeah, that's my pitch.
Great. Thank you so much, Anna. Do you also want me to post the link for the Google form you created to see if people are interested?
Yes, that would be great.
Perfect. So I'll just post, this is just a link to see if people are interested, and then we would start hosting a book club. Thank you for the great idea, Anna. Also, a few minutes ago, I posted a link about giving us feedback. So please click on that link. We're not asking for any personal data. This is just so we can make our events better and see if you like this one. So thank you all for coming. And I look forward to the next PyLadies London and Elastic EMEA virtual event soon. And thank you again, Lisa. Have a great evening or rest of the day, everyone.